I haven't even changed the slides. I wanted to start with a story. In 1936, in the latest stages of a very illustrious career, but still very active, Albert Einstein submitted a paper to the Physical Review. He sent the paper in. The editor sent the paper to someone to review. And he got back a 10-page report with questions about the paper, which he sent to Einstein. Einstein was furious. He sent back a very angry letter to the editor saying, more or less what it says there, I did not give you permission to do this. You were not allowed to do this. His expectation was that the editor would receive the paper, maybe glance at it, and publish it. So the idea that someone would be checking his work felt completely foreign and alien. He withdrew the paper and never published in Physical Review again. Today, the idea that an article you submit to a journal is peer-reviewed is so natural that it's actually the definition we use for a journal. A journal is a journal if it's peer-reviewed. But that was not always the case. And so the idea that the practices we have, the systems we have, the tools we have that underlie how this work have changed and evolved is something that we can forget sometimes. Right? The things we do feel so natural and feel like almost facts of nature, but they were designed. They were things that evolved and changed. Why did they change? Well, here's another picture. It's a famous picture from the 5th Solvay conference. I like physics examples because like Tim, way back in my history, I studied physics, so I'll stick with those. There was a famous conference, the 5th Solvay conference. And in this picture, you see 29 people. 17 of them went on to win Nobel Prizes. In one case, the person won 2, Marie Curie at the front there. This conference is famous because it brought together the people who developed the foundational ideas around quantum physics. Quantum physics underlies essentially everything in our modern world. All of chemistry, all of electronics relies on what this group did. 29 people. You can fit them into a room much smaller than this one. Right? This is part of the reason why the idea of doing peer review wasn't natural to them. They were working in a small group. They knew each other. There was a relatively small number of institutions that worked together. This was their world. By reputation, by proximity, by just habit, they didn't need some of the systems around vetting the work and validating it. Almost everything they did was published, and their own personal reputation and their own personal relationships kept the system going. This is not the world we live in today, right? For many reasons. Let's talk about some of those reasons. What's changed over the last 100 years, or 50 years, or 20 years? I'm going to call out 4. Many things have changed, but let's call out 4. One is science is now truly global in a way that's hard to fathom. Tim talked about Elsevier being a global company, and we truly are. We operate in every single country, more or less, with a couple of obvious exceptions. And the reason is because it's truly a global enterprise. There are many numbers you can do to put this. I pulled up one, which is to say that, what does it say, 1996, if I remember my slide correctly, 15% of the papers published by US authors had an international collaborator. Today, the number is about 40%. And those collaborators come from all over the world. But that poses questions. This is not a small room of people who know each other intimately over many years. This is millions of people working across the entire world, producing millions of papers every year. How do you manage that? How do you manage that complexity? How do you find the people to collaborate with? How do you know you're collaborating with the right person? These pose different kinds of demands and require different kinds of systems and tools. Here's another change. Back in 1927 or 1936 at this conference, effectively, they were doing it out of intellectual curiosity. They were trying to solve problems around, well, how did the world work? This is a fantastic thing. But increasingly, other stakeholders, general public, funders, governments, are asking for really more evidence that what people are doing in scientific research or in academic activities is having some benefit. Right? You can phrase this in crass commercial terms. Is there a return on investment on our funding? Is there a reason for doing this? You can phrase it in actually more, not commercial, but if you like, existential questions. Why do I, as a taxpayer, support this? Why do I do this? Tim talked about this. What do I get out of this? Right? Why does it matter to me? Right? It can feel like a very small question sometimes, but it's a real question. And for people who are struggling, who don't have as much as others, it's a fair question. And so the demand becomes, there's a report that Elsevier worked on last year about the future of evaluation. And I won't go through all the details, but it really was the idea. We spoke to many academic leaders from across the world, and they recognize that the way in which we assess or evaluate or talk about research requires a broader perspective. So they talked about things like we need more emphasis on societal outcomes, being able to demonstrate those. More inclusive approaches to evaluation that reflect both global trends but also local needs. How do you influence your community? Why do you matter to the state of Illinois, for example? They talked about the idea that assessment systems drive cultural change. This is something that's very familiar, especially to the people who work in faculty affairs. The choices you make around how you assess people, what you're asking them to do, how you measure them, really will drive their behavior. People respond to incentives. And so that also gives you a responsibility, though. The choices you make about how to set those systems up will materially change the kinds of impact your institution is going to have. And then there was, because we will have to talk about it, a question about ideas about AI. But the reason why they talked about AI is interesting. It was really about trying to deal with the fact of the sheer scale of the problem. Millions of papers in increasingly narrow subfields that can only be truly understood by experts. How do you make choices in that? How do you assess what's good and what's not good? Right? It's a much harder problem than it was when everything was smaller and fit into a room. And so thinking about new technologies, thinking about ways in which you can use AI and AI-based technologies really to filter through or to sort or to summarize this complexity, that was another thread that people are thinking about. Here's a third one. Everyone's favorite. Compliance requirements. Here's a study by the Council on Governmental Relations, which is an industry body that looks at this. And it's looking at, well, what's changed? What more things is the federal government, this is the US federal government example, asking for? Right? You could draw this graph globally, though. Right? And here's some facts. It says 60% of regulations that have changed since 1991 were issued in the last 10 years. Okay, that was 10 years up to 2024. But what it means is the speed of which people are asking for more things, asking to track more things, asking to justify more things is growing. Why is it growing? Well, for a whole bunch of reasons. I've listed some there. Right? Cybersecurity, national security, conflicts of interest, shaping research practice. Right? Less important than any individual point, and it doesn't really matter how you feel about any particular point there, the important takeaway is that these are real concerns. They're not going to go away. People are not going to suddenly feel less concerned about national security or less concerned about ethics in research, right? But the sum total of this means that it adds an additional burden on everyone doing academic research. There's more things to track, more things to report, more things to be concerned about. Each individual thing is there for at least a reasonable reason, right? But the sum total of it can add quite a lot of complexity to activities. It risks choking the time you have to actually do the real work in this problem. That is a hard problem to solve. The needs are not going to go away. How do you respond to them? Here's a fourth one. The actual practice of research itself. Are people doing good work? And good work can range from, are we doing sufficiently smart studies with large enough sample size, to are we actually making sure that there isn't fraud and manipulation in the data, right? That has been a challenge. There's a huge degree of debate about reproducibility and transparency in science, right? These factors go together, right? More pressure on people, more competition, all of that can lead to a drive to get something out there, publish something, do something, tweak the numbers to do it, right? Multiple factors are doing this. In some fields, psychology, medicine, social sciences, and so on, was a really big problem. And so people started to think about what are the things we can do to change the practice of how scientists work or how researchers work to improve that. So then you had things like, for example, pre-registering clinical trials. So you can make a prediction. You're not just back engineering it afterwards. You had a particular hypothesis you were testing. Right? Open access, open data, sharing things, sharing code, giving people the ability to go in and check what you did was correct, or to build on what you did to reduce the cost of recreating data sets. Right? These are fundamental changes in the culture and practice of many of these research fields. How do we support those? How do we give them tools and platforms to enable them to do that? So these are, and there's others, I could carry on, but I say I'm running out of time. These are consequential changes. And universities, institutions, governments have invested in tools and systems to enable these, some of which are represented by the tools and systems we're talking about here. Systems like Interfolio to manage academic lifecycle events, or Pure to collect and use research information, right, for showcasing, or for, in some other countries, national assessments, right, or managing grants. Digital Commons, creating platforms to capture that experimental data, or to showcase the work, or to create journals that you launch. There are many, many use cases. Right? And it reflects, I think, a large amount of the complexity that's been created, or we've built around this. The challenge for us, though, is what's next? These systems are not perfect. There's more we need to do. There's work that we need to do. We will tell you about some of the things we've been doing over the next 2 days. But more broadly, there's a vision we have for where we would like to go with this portfolio. And so I wanted to share with you not specific features or things we're going to launch, because you're going to hear about those very shortly in sessions later today and tomorrow. What I wanted to share with you are a couple of design principles for how we think about how we want to support you and your institutions with the systems we build. So here are 4 design principles. The first is the idea of, it's a tagline we use around faculty first, right? Which we inherited from Interfolio, and I really liked it. Right? But it's a bigger concept. It's the idea of these systems are there not because institutions want systems, but to support academics. Right? Those are the ultimate reason why these systems exist. And so we shouldn't forget that. We want to, as software developers, as product builders, design systems that work for the true end users, for the academics, the faculty, students in some cases, who are actually using these systems. Are we making it easy to use? Are we minimizing the demand of their time? Are we asking them to redo things that they've already done in multiple systems? Right? The more we can do to free up their time, to allow them to meet the needs of that greater complexity, but do it in a way that doesn't demand too much of their effort and too much of their time, which they should be doing, or should be spending on doing the actual work that they're hired to do, those are better systems. Right? So think about the end user. That's a big design principle for us. The second design principle is a lot of these systems rely on, or are essentially designed to, collect data from across your institution. That common data view is critical for the decision making you need to do, or for the academic processes you need to run. So we want to think about, how do we help you build that data view as effectively as possible? How do we enable you to pre-fill these systems with data from public databases, for example, or the databases that Elsevier has collected, in order to reduce the work that you have to do as administrators, or reduce the work that faculty have to do to populate these systems? How do we enrich that data in ways that allow you to extract new insights? The third design principle is really the recognition that you don't have one system. Right? I talked about a couple that are represented in this room, but there are many other systems. There are student information systems, there are your HR systems, your finance systems, your grant management systems. Right? This is a complicated landscape. Right? And very often, too often today, these are very much disconnected silos. Right? You very often have duplicate information, or the same thing in different places, or you have different parts of the university who have acquired different tools. Right? Part of what we see as a design principle for us in the future is thinking, how do we help you bring some order to that complexity? How do we build more interoperable systems so you can reuse data that you've curated in one place and other places? How do you build journeys across these so you allow people to use and interact with these tools more effectively? How do you build common design patterns so actually we're using the same language about things and you're asking people to relearn different ways of doing things? This is a journey. It's not something that's going to happen overnight. But this idea of helping you build a more coherent system landscape, that's something we want to invest in, and that's something we see ourselves as having a responsibility to help you bring some order to that complexity. I was going to say chaos, but let's be kind. Complexity. And the last one is, having done this work, having assembled all this data, how can you take better advantage of it? How can you start to deliver new insights, new capabilities built on that data? More analytics, more sophisticated reporting. Right? These design principles, they're not an end state. They're not a goal. It's not a thing we're building. You'll hear more about the things we're actually building. But they're more about a philosophy of how we're approaching it, what's important to us. And I think that philosophy is important because having a good sense of these design principles helps us stay on the right track in terms of building the right thing. Right? Because it's easy to build the wrong thing. It's easy to go through a long feature list and just tick off, have we ticked all these features and done that, and delivered that. Right? And honestly, sometimes you have to do that because we have RFPs and tenders and so on. But there's a world beyond the RFP and the tender. There's the day-to-day reality of what does it actually feel like to use these systems in your institution when people are doing it. Are they working with you? They're working against you. I'm actually now going to use Tim's word, which I hated when he put it up, which is magic. As a physicist, I don't want to see magic in an equation. But that idea of making the experience a little bit more magic, right? A little bit less friction, a little bit nicer, and doing that consistently every time we think about a new software release or a new thing we bring. That idea of incrementally trying to improve it along these dimensions, I think, is at the heart of how we think about the future of this portfolio. Someone asked me when I was talking about this, there's a word that's not on this page anywhere, which is AI, right? Hey, it's a tech conference. Shouldn't I be talking about AI? And we will. But AI is not a separate thing. AI is an enabling technology that underlies all of these. So when we think about building better user experiences for end users, AI-based tools will be part of that. When we think about taking more advantage of your data, AI-based tools are part of that. We launched a new one a few weeks ago called Pure Impact AI, which you'll hear about in one of the sessions. But it's the idea of embedding AI as an enabling technology in everything we do, not as it's a separate thing that we're going to do. We're not doing AI. It's about making everything we do better through all the technologies we have access to, including AI. I think that's an important point because it's easy to get distracted by whatever is the current big thing, right? And for good reasons, because sometimes the current big thing holds a huge amount of promise. But that promise needs to get translated into things that actually work for people, that allow them to do the things they're trying to do better. Because really, they're not trying to use these systems. That's not the point. They're trying to achieve some other goal. And we're trying to enable that goal. So I'm really excited about the next 2 days. We're going to show you lots of stuff. We're going to show you many things that are currently available that hopefully make your lives better, things we're working on that are going to come out of the next year. And so please go to these sessions, but also give us your feedback. As much as we have ideas about things we want to build, we also rely on you and these conferences to give us feedback on where are we falling short? What are other things we should fix? What are things that we're missing that we could be doing better? This is a fantastic opportunity for us to learn from you, but how do we actually deliver on the vision we have? I'm going to end by telling you how this story finished. So Einstein withdrew the paper and eventually was published in another journal about 3 months later. However, and here's the kicker, the reviewer who sent him the review was absolutely correct. The paper was wrong. There was a fundamental error in it. It's not obvious from the evidence whether he actually read the report. In fact, there's some strong suggestion that he didn't bother reading it. If he had read it, he probably would have saved himself a couple of months of work, eventually realizing there was a problem and fixing it. Right? What can you take away from this? Well, one is your users won't always appreciate what you're doing when you build better systems. But if you do it right, if we truly do it right, then you fundamentally will help them achieve better outcomes. And more than the design principles and other things we do, that's honestly why I do this job and why this team does the job is, can we help people fundamentally deliver better outcomes at the best we can? Even for possibly the greatest scientists in the world, we can help them do that.